Okay, so in this video I'm going to talk to you about fractions and more importantly about equivalent fractions. Let's start off with talking about what a fraction is. So you can see on the screen we've got the fraction 1/2. It has two parts to it. It has a numerator and denominator. So with the denominator, the denominator tells you how much to split any particular shape or amount of money or whatever it happens to be. It tells you how many pieces to split it into. So if I was to show you on this first circle here, if I put a line down the middle, I am cutting that circle into two pieces. Now, because I've got 1/2, that means that I'm actually only looking at one of the halves. Okay, so I'm just looking at a half of my whole circle. So just the shaded part. So that is a visual representation, if you like, of what 1/2 is. I can split my shape into different amounts and still have the same size piece though. So for example, if I was to split this circle into 4 pieces, I've now split it into quarters. Now if I was then to shade the same amount of the circle as I have done in the first picture, you can see that I've got the same amount shaded, but I've got 2 pieces shaded out of 4. So that means that 1/2 is the same as 2 quarters. Okay, so it's the same amount that I have, but I've described it differently. So I'm saying I'm splitting my circle into 4 pieces and I'm shading 2 of them. Now that means that 1/2 and 2 quarters are known as equivalent fractions. In other words, they give the same value, but they just look different. Now in terms of the maths, what we can do to get from 1 to 2, we multiply by 2, so we have to do the same to the denominator. So in order to compare equivalent fractions, whatever happens to the numerator has to happen to denominator, whether it's multiplying or dividing. We only do it by multiplication and division, not by adding and subtraction. That wouldn't work. I can do the same again if I this time split my circle up differently. So if I split it into quarters and then put another 2 lines very carefully down there, okay, and again I can shade the same amount of my circle in, but again you'll see I've now created a different fraction. So altogether this time I've got 8 pieces, so that's my denominator is 8, but I'm only shading 4 of them, so that's my numerator. So I've shaded 4 out of 8, but if you look at the other 2 diagrams, I've got the exact same amount of my original circle, which means that that is also equivalent to 1/2. And this time what I'm doing is I'm multiplying the numerator and the denominator by 4. Okay? So that gives you a visual representation so you can see what's actually happening. What we can then do is have a look at some questions and the kind of thing that you might get. So here, the top 2 ones here, we've got a fraction and we've been asked, okay, what is the missing number? So what is the number here which makes this an equivalent fraction? So what we need to do is look at what we're multiplying by. So 4 times what gives us 16, and we can work out that that's 4 times 4 is 16. So we'd have to do the same to the denominator to keep our fractions equivalent, otherwise they're not equivalent. So therefore 5 times 4 would give us 20. Okay, so that would be 20. So the answer would be 16/20. Okay. On this one, we're going in the opposite direction this time. So this time we've got to work out how do I get from 81 down to 9, and the answer is we're going to divide by 9. So 81 divided by 9 gives us 9. So I've got to do the same to the numerator. So 27 divided by 9 gives me 3, which means the answer for this one is 3/9. Okay. Now some questions they might say to you, give your answer in its simplest form. So what we're looking for is to cancel down a fraction to get it as simple as possible. So if we look at 3/9, we'd then be looking at what numbers, are there any numbers that go into both 3 and 9, which means I can divide down even further and you can see you can get 3 into 3, which would give you 1, and 3 into 9, which would give you 3. So we could divide top and bottom by 3, so we could divide it further down, and this then is called its simplest form. So in other words, when I look at this fraction, there are no numbers that go into both the numerator and the denominator. Lastly then, I've just got some examples here of fractions that we can convert to either from improper to mixed number or a mixed number to an improper fraction. So 15 over 2, we've got to think to ourselves, how many whole ones can I get out of that? So if you think about it, what you're really saying is, how many times does 2 go into 15? Well, it goes in 7 times, because 7 times 2 would be 14, and then I've got 1 left over. So therefore it's 7 whole ones and 1 half. So you could think about having the 7 circles that you could fill up with halves, and then you'd have 1 left over. 23 over 4, think again, and it's really important to know your times tables. So 4 goes into 20 5 times, okay, and then there's 3 left over, so that would be 5 3/4. And then this one, if we go the other way, we say to ourselves, I want to turn that into a top heavy fraction, so just as a single fraction. We've got 5 whole ones. How many fifths is that? Well, we do the opposite, we multiply. So 5 times 5 is 25. 25 plus 3 is 28. So that as a top heavy or improper fraction would be 28 over 5. Okay.